Welcome back, and now we're on part 2 of physics of the atom. So now we're going to deal with electrons, the nucleus, and the periodic table. Experiments have now shown that there are 3 types of different particles which make up the atom. What are they? Of course, you know them because we did them a while ago. They are the electrons, protons, and the neutrons. Neutral atoms have the same number of electrons and protons, and if you've seen a periodic table, it's the neutral atoms that the periodic table display, right? So that is where they don't have any charges. So whenever anybody asks you how many protons, how many electrons are in this atom, you just look at the atomic number, okay? And that probably went over some people's heads, but we're going to get to that just now. Now, protons and neutrons together are referred to as nucleons, and that is what actually gives the mass number for the element we are referring to. Now, I have a little table here with the proton, neutron, and electron, and we want to know the location of them. So, let's write it in. Now the proton, the location in the atom would be the nucleus. Correct. And the electric charge of the proton would be +1, or +1. For the neutron, the location of the neutron is also in the nucleus of the atom, and the neutron doesn't have any electric charge. And the electron will be found outside of the nucleus. It will be found in the energy levels are the shells, so the energy shells. And if you wrote outside of the nucleus, that's perfectly fine. And the electric charge of the electron is -1. Awesome. The atom. So let's do a little overview of the atom. The atom is composed of protons, neutrons, and definitely the electrons. Protons and neutrons can be found inside of the nucleus, whereas electrons will be found outside of the nucleus in what is called energy levels or energy shells. The mass of the atom is attributed to the weight, or the mass, let's not say weight, the mass of the protons within the nucleus. The mass of an electron is very, very small. It's 1 over approximately 1800. So 1 divided by 1800 will give you a very, very, very small number. So it's referred to as negligible. Like, you don't really pay attention to it. It's like saying 1 plus 1 over 1800. You know, that would be 1.0000000. God knows how many zeros. Okay, so the atom can be looked at, the schematic, or the way we view the atom is comparable to the solar system, where we have the nucleus is like the sun, and then we have the electrons just like the planets that orbit the sun in our solar system would be. Yeah, so the electrons would be the planets that orbit the solar system, the sun in our solar system. Okay, so yeah. Now, when we want to break down the atoms, that's why we always encourage students to learn chemistry, take up chemistry when you're learning physics, because they're intertwined, they work well together. You have to learn it, because then for those people who know chemistry, they'll feel comfortable and they'll be familiar with the material by the time we reach this section. However, for those persons that have not learned chemistry, or are not engaged in learning chemistry, or don't have any interest in chemistry, guess what? If you're studying physics, you have to know some chemistry, and you feel a little bit uncomfortable and left out. But here I am to help you a little bit with chemistry. So, electrons can be located in the energy levels, like we stated before, and the first energy level would hold a maximum of 2 electrons. That's the first shell immediately after the nucleus. The second shell would hold a maximum of 8, and the third 18. We don't really go any further than the third shell. The third shell has 2 subsets. So you will have 8, then 10. Right? So you have a little mini shell with 8, and then the next one could hold a maximum of 10. And when we do a question, you will see what I'm talking about. For example, we have carbon. Carbon has 6 electrons, so therefore it would have 6 protons, right? So it's 6 protons, because we know protons and neutrons are found inside of the carbon atom. Note well that what we're going to do is, let me clean this up. We're going to do this again. So put it more here in the center. So we have here, we're going to have 6 protons, and the mass number of carbon is 12, so we have 6 neutrons. So those two together would be 12, and we have the first shell here. So what we want to do, we know that carbon has 6 electrons, right? We know the first shell, which is this one. Let me use another color for the first shell. We know the first shell. Let me use a whole different. Can I get another color? No. Alright, so the first shell holds a maximum of 2. So we can minus 2 electrons from the original count, and we know that 2 electrons will go here. So pretty much that's all that this shell can hold. However, we have 4 more electrons that we can play with, and we know from the previous page that the second shell can hold a maximum of 8, but we have 4 here, so it can hold that. And note how I'm putting them in. Electrons always repel each other, so you want to put them as far away as possible from each other. So we always start filling our shells at the 12, just like a clock. You have a clock, so we want to fill it out at the 12, the 3, the 6, and the 9 o'clock positions. Okay? So for this one now, we said the electronic configuration is 2, 4. 2 being the first shell has 2 electrons, and the second shell has 4. And these 2 numbers tell us that carbon is in period 2, and we'll get to that just now. And it's also in group 4. So 2 numbers, 2 numerals tell us the period, 1, 2, and the number on the left hand side, the last number, tells us the group, which is 4. So maybe we could try the next one. Magnesium is an element is an atom with an electron count of 12. So we're going to put in here 12 protons. It also has a mass of 24. It's not there, so we're going to add the neutrons here. So 12 plus 12 is 24. So the first shell holds 2. Right? So that's at the 12 and the 6 o'clock positions, as far as where it's possible from each other. So if you have 12 electrons, if magnesium has 12 electrons, then the first shell holds a maximum of 2, so you subtract that, and you have 10 electrons to play with. Now you know that the second shell holds a maximum of 8. So we have 1, 2, 3, 4, 5, 6, 7, 8. And so we're going to subtract 8 from here, and we have 2 left over. So we therefore know that the last shell, we therefore know that the last shell can hold a maximum of 18. So we're going to just put here the 2 electrons out here. Okay, and our electronic configuration will be 2 for the first shell, 2, the second shell is 8, that's 10, and then the last shell holds 2. So we know that this element is in period 3, because we have 3 numbers, 1, 2, 3, and group 2. Alright, now do note that you will have to learn the names of the first 20 atoms. You're also going to have to learn the symbols, right? So if you didn't notice, you see that carbon has a symbol C, and magnesium has the symbol Mg. Okay? Now each atom is different. They're depicted in the periodic table as I have here. So these are the first 20. You have to learn hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, argon, potassium, and calcium. Okay, so you have to learn the first 20 elements. You also have to know the protonic numbers or the atomic numbers, which are usually at the top. So we know hydrogen is the first atom, that's 1. Helium is 2, 3, 4. And usually the larger number that is present in the periodic table in the square, in the little square, is the mass number. So the smaller number is the atomic number, and the larger number would be the mass number of the element. So you can see it here, the periodic table. The first group is known as the alkali earth metals. The second group, the alkaline earth metals. So this is group 1 and group 2. So groups are the columns that travel down, and periods are the rows that travel across. Then we have another, this is group 3, sometimes referred to as group 13 if you include the transition metals. All of these are metals excepting boron. All of these, the first 3 groups are all metals except boron. And then we get to the non-metal section, as we would like to call most of these. So these are non-metals. So you have the carbon, which is group 4, carbon group, nitrogen group, which is group 5. Then we come up to the halogens, which is group 6. Sorry, not the halogens yet. So we have group 6, which is oxygen, and then the halogens, which is group 7. So we have fluorine, chlorine, bromine, iodine, and astatine. So the rhymes, these are the halogens right here. And then we have noble gases. Pretty sure that I have it written down over there, but just in case I don't, we have the halogens, that's group 7, or group 17. We have the noble gases. Oh, it doesn't. Noble gases as group 18 or 8. These are all non-metals, by the way. Everything over from carbon and non-metals, except in those in the blue, which referred to as metalloids, which have some type of metallic character once they become doped, and that's a whole different story again. And you're probably going to learn that in electricity when I get there. And then we have, these are the alkali, group 1 alkali, earth metals. And these are the alkaline earth metals. Okay? So yes, and if you didn't realize that this down here should be in here, and usually the periodic table will be this size. If you include down here the lanthanides and actinides, what's going to happen is that the periodic table will get too wide. So that is why this set is down here, just for aesthetics, basically. But if it were, you would have a very long, wide table. Now, all elements in their natural state are represented within a periodic table, and they're categorized based on their groups and the periods. So groups run vertically, while periods run horizontally. So vertically across, vertically, my bad. Vertically would be, yes, you got it, straight up. And horizontally, just like the horizon, is across. So we have one up, back and forth. So groups indicate the number of valence electrons an atom has, while periods indicate how many energy levels an atom has. So by valence electrons, we are referring to the electrons that are available for bonding. These are the electrons that are responsible for all the chemical reactions that you know of today, right? So for instance, when we had carbon over here, carbon has 4 valence electrons and it's also in group 4, whereas magnesium has how many valence electrons? 2. So those 2 electrons are available for bonding, and these 4 electrons in carbon are available for bonding. For example, the sodium atom is in group 1 and period 3, therefore sodium has 1 valence electron, whereas and 3 energy levels. So you would see that sodium is in group 1, period 3. And is it true? Let's go back. So we look for sodium. Here is sodium. So this is group 1 indeed, and this is period 3. So we are correct right there. Valence electrons are those electrons available for bonding. In other words, they make bonding between atoms possible. And the proton number may be referred to as the atomic number and is represented by the capital letter Z. Sometimes they have different notations, but in this case we're going to say the atomic number is Z. The total number of protons and neutrons make up the mass number, and they're referred to as nucleons. Okay, and we represent that as the letter A. So look at it here, we have A and Z. So A would be the mass number in this case, and Z would be the proton number. So in this case, if we have magnesium, magnesium has a mass number of 24, whereas it has a protonic number or atomic number of 12. Okay, and like I told you, the mass number is always larger than the atomic number. Okay, so X would stand for the symbol. Right, so X stands for the symbol. The neutron number may be determined by subtracting the atomic number from the mass number. So note well, to get mass number, you add the atomic number. Well, no, let me say this. To get the mass number, what would you do? Right, you add protons plus neutrons to give you mass number. Once you know how to do this, you could just transpose. So therefore, mass number plus protons, mass number minus protons, mass number minus protons will give you neutrons, and mass number minus neutron will give you protons, right? Write out the atomic notation for the following. Magnesium, which has an atomic number of 12 and a mass number of 24. So we could do this. So you could start doing this as well along with me. Boron, which has an atomic number of 5 and a mass number of 10. So we're going to say boron. We're going to put 10 on top here and 5 at the bottom. And iron, which has an atomic number of 26 and a mass number of 56. So we have iron, 56 on the top and 26 at the bottom. Now once you know this, it says for the above, determine how many protons are present in each of the elements stated. Once you know the atomic number states the number of protons present. So 12 protons And so boron, we know boron has how many protons? 5 protons. And iron has how many? 26 protons. So once you have the notation, you'll be able to do these very easily. So we know you're dealing with isotopes now. So nuclei of a neutral element always have the same number of protons and so have the same atomic or proton number. Sometimes the nuclei may contain different numbers of neutrons. In this case, atoms with the same proton number but different nuclear number are referred to as isotopes. For example, the isotope carbon has 12, 13, and 14. So there are different types of carbon. They're all chemically the same, but they have different number of neutrons in them. However, the same number of protons. If you look at the number down here, you would see they all have the number 6, so they have the same number of protons. However, so this would have 6 neutrons. This would have 7 neutrons. And guess how much this would have? Oh, correct. 8 neutrons. So here the atomic and the proton number are the same. However, the neutron count is different. And I just did it for you. As proton number identifies the name of the element, it is more convenient to write isotopes in a simpler format. So instead of writing the carbon 12 with a 6, carbon 13 with a 6 and stuff, it's the carbon 12, carbon 13, carbon 14. The nuclei that share the same number of protons and neutrons are referred to as nuclides. So carbon 12, 13, and 14 are nuclides of each other. So we have the check comprehension section. So what you can do is to try to answer these on your own time, right? So you could pause the video and try to answer them and then play it again so you would have time to see if you have them correct. Great, so now that you've done the test, the comprehension quizzing, you can answer this question. So fluoride has a proton number of 9. How many electrons does a neutral fluorine atom have? Right, 9. So sketch the arrangement of these electrons. So we have fluorine, 9 protons. So therefore having 9 electrons. So the first shell would hold 2. The second shell, we said 9 electrons minus 2 will leave back with 7. And you know the maximum amount of electrons the second shell can hold is 8. So we can go ahead and fill out. And we know that if you had 8, all of the x's would be paired. But since we have 7, we know that one of the x's would not be paired. So we have the electronic configuration being 2, 7, which shows that fluorine is in group 7, period 2. So in what group of the periodic table is fluorine placed? Group 7. And now we have copy the following table, then calculate and fill in the missing values. So we have here carbon has 6 protons, that's a nuclear number of 12. So the number of neutrons would be 12 minus 6, which will give us 6. And the number of electrons will be equal to the number of protons because they are neutral in this sense. And here too, we could just work out the electron number one time, which is 11, because we have 11 protons. And so the nuclear number would be the addition of the protons plus the neutrons. So 11 plus 12 is equal to 23. In this case, we have 79 electrons for gold, so therefore you will have 79 protons. The nuclear number is 197. Nuclear number is also mass number, if you forgot. So therefore, to figure out neutrons, you will say 197 minus 79. And that should give you a nice number. What's the number? So, right, so 197 minus 79 will give you 118. Oh, yes, so 118. And then now we have osmium, so we have the number of protons. So you could just put it back on the electrons. And then you want to know the nucleon number. You just add the protons plus the neutrons. So 76 plus 114 will be equal to 190. So 190. I hope you got these answers. See you around for the next installment of part 3 of physics of the atom. Bye.